Alright everyone, so we're going to go over some algebraic concepts today. More specifically, going over solving algebraic equations with integers. So it's going to be both negative and positive numbers. They're not going to be rational numbers with decimals or fractions. We're just going to stick to the basics here. So, what is algebra really? Well, algebra uses letters such as x and y or other symbols in place of values, and then it kind of like plays with them using special rules called inverse operations. So we're basically going to reverse every single operation in order to come up with the value of x. It is all about balancing both sides of the equation. That is the main concept of algebra, the relationship between one thing and another thing. All right, so our most important goal is going to be to isolate the unknown variable. Okay, so if we look over here, we can see that we don't know what x is. Okay, so we need to get this x here by itself. All right, that is the entire goal. So I've represented this over here on this scale. All this is saying is that whatever 3x plus 7 is, it has to be equal to 19. All right, so this side has to be equal to that side. So whatever I do on one side of the equation, I have to do on the other. Now, for the purposes of this video, I suggest you do this. Go ahead and draw a line in the middle so you can separate both sides. In my future videos, I won't be doing that because I'm already comfortable with the other way. But first, starting out with solving these, you should probably draw this line. Okay, so always opposites. I want to get this x all by itself, so that's going to be the last thing I touch. So let me go ahead and reverse this. So to reverse a plus 7, I have to minus 7. So minus 7 on both sides. Okay? Now, take that away. Now, we have 19 minus 7. 19 minus 7 is going to be equal to 12. So we have 12 here. This is nothing, so that's 0. I can leave that blank. But this 3x, we didn't really do anything with, so let's just bring it down. So we have 3x is now equal to 12. Now, at this point, there's no addition or subtraction sign, so what do? You have to inverse either a multiplication or a division sign. In this case, this is saying 3 times x equals 12. So to reverse a times x, I'm going to go ahead and divide by 3 here. So I'm going to divide by 3, and I'm going to divide by 3. So I get x is equal to 12 divided by 3 is 4. So 4 would be the correct answer. Now, let's plug in and see if that's true. We have 3 times 4, because we're saying x is 4, plus 7 equals 19. 3 times 4 is 12. 12 plus 7 is equal to 19. 12 plus 7, yes, 19 is equal to 19, so we know that we did that correct. If you're ever unsure whether your x is correct or not, please just make sure to go back to the equation, plug in for whatever that unknown variable is. It could be x, it could be y, it could be z, it doesn't matter. But for whatever value that is, just go ahead and plug it in to see if you got it correct. All right? Now, let's go on to just 4 more problems. You'll see these in different ways. What really confuses kids are these negatives and the subtraction sign. Okay? So, if I wanted to, I could have rewrote this to 3x plus negative 4 is equal to 2. So a lot of people keep asking me, is this a subtraction sign or is it a negative sign? Well, both. Technically, it is a subtraction sign, but technically, if you reverse it to its addition property, it's just saying 3x plus negative 4. Okay? So let's go ahead and inverse this. The opposite of negative 4 is positive 4, or the opposite of subtract 4 is add 4. So this is gone. Now I have 3x is equal to, what's 4 plus 2? 4 plus 2 is equal to 6. Okay? So remember, we got to get x all by itself. This is saying 3 times x equals 6. So the opposite of multiplication is division. So I'm going to go ahead and just divide by 3, and I'm going to divide by 3. Alright, so now I get x is equal to 6 divided by 3 is 2. So x is equal to 2. Now does that make sense? 3 times 2 is 6. 6 minus 4 is equal to 2. So yeah, that's definitely correct. Now, over here. Looks a little funky, but it's just because it's on the other side. Now if you want to, you can just go ahead and inverse this. So negative x plus 6 is equal to 1, and that helps you see it a little bit better. But once again, I have to work on the side with the variable first. So I can't touch that yet because of this addition sign. So I'm going to just go ahead and subtract 6 and subtract 6. Opposite of plus 6 is minus 6. remember it's all about opposites, equals negative x. And you got 1 minus 6. Now, of course, if you don't know your integer rules, just go ahead and use a calculator. But if you're at 1 and you take away 6, you're in the negatives now. So this is going to be equal to negative 5. Okay? So we have negative x is equal to negative 5. I don't want negative x because what this is basically saying is this is negative 1x. Okay? So I'm going to divide by negative 1 in order to get the x all by itself. So I'm going to divide this by negative 1. So we got 5 is equal to x, or x is equal to 5. Let's plug in and see if that makes sense. Negative 5 plus 6 is equal to 1. Yes, that's definitely correct. Now, over here, you might be tempted to want to do subtract 2x. But remember, we can't get to this until everything else is gone. So the opposite of a positive 5, you can see that this is a positive 5, is going to be minus 5, minus 5. So we have 2x is equal to 12. Now, got to get the x by itself. Divide by 2, divide by 2. So x is going to be equal to 6. Alright, let's double check. 5 plus 2 times 6 is 12. So 12 plus 5 is 17. So yes, that's definitely correct. Alright, let's go with the last one. Once again, can't touch that yet. An addition or subtraction sign is in the way. So opposite of minus 4 is add 4. Let's add 4. Negative 34 plus 4. Let me actually just go ahead and do that. And forgot about that over here too. There you go. So this is going to be equal to 70. That's gone. Negative 7x. So let's divide by negative 7. And let's divide by negative 7. So x is going to be equal to negative 10. Negative. Alright, and there we go. I forgot to put the negative here, so this should be actually a positive 10. Alright, there we go. Alright, that's it.